All right. So today we've got a workshop that really focuses on using Git and GitHub for collaboration. I know we've done some of this, so some pieces of this will be review, but I can pretty much guarantee some other parts will be new. There's a couple parts here. I'm gonna start off talking about, and can everyone see this font size? Okay. I'm going to start off talking about what we're calling either the golden rules of Git or tactics for team productivity, things that both help you avoid gotchas and will help you guys be more productive in using Git and GitHub. We're going to then kind of demo the sort of standard workflow for collaboration on Git that's called the feature branch workflow. And we'll talk a little bit about pull requests and code reviews and see some examples from real world projects. And I'm gonna get a volunteer and Jay, thank you for volunteering when I chatted with you earlier. To demo this, we're then going to demo causing a merge conflict where two people try to modify the same bit of code and Git doesn't know what to do with it and how to resolve it. And that's going to be the big one. And then we are going to, I have an assignment for you guys to do in your teams where you'll have a full stack Pokemon app with all the code written out, but each person will have just a tiny slice, and you'll have to make a branch and a pull request and merge it, and you'll have to communicate and coordinate amongst each other and figure out the sequencing of things. And that's to sort of put this stuff into practice. Um, we're not there yet, but the code base I'll be using to demo this is this Avenger Git Workshop 2 code base. We're going to pretend that this branch named main2 is our main branch. And I'll drop this link here in the Zoom chat, and everyone should have access to this. And this is a pretty minimal Flask app. And we're going to be modifying some things like students and some other things, but we'll get there when we get there. We're not quite there yet. And then this workshop itself is in a separate repo that is in our Code Platoon curriculum GitHub org, but I'll drop that link in here. You can also find it if you go to the README for the org itself. It's linked over here. Any questions about the agenda before we dive on in? All right, cool. So let's talk about some tactics for team productivity. Some of these will make sense now. Other of these will make more sense as we get deeper into the lecture, but I want to kind of walk through these now so they're sort of in your brain. These are tactics that come from just a lot of real world engineering practice. And not only are they going to help you on your group project, but they're also going to be useful to talk about. So they're written out here, and we have this handy dandy slide deck. So let me kind of walk through these and talk about these briefly as we go. And some of these are about Git and GitHub specifically, and some are about workflow. So these 10 tactics are going to be always protecting the main branch and making sure it's in a good state and the code can run, daily stand-ups, breaking work into small chunks, merging to main often, doing code reviews for everything, identifying work that we can do in parallel, learning how to fake data or mock data, practicing a sort of agile sprint, doing some pair programming, and choosing someone who will be a manager on your team and someone who will be a leader, right? And sometimes this is the same person, sometimes not. So let me just kind of walk through these and please fire away with any questions as I do. As I said, some of these I think are straightforward and you may already be familiar with, some are newer. So I actually snuck one in here. This is sort of the golden rule of collaborating. The goal here is, and this is what we're going to learn with the Git feature branch workflow. We really want to avoid two people modifying the same bit of code at the same time. This is going to be the easiest way to avoid merge conflicts and confusion. And to do this, you're going to need communication. Related to this one, we'll see the feature branch workflow in a minute, basically where if I'm working on adding the front end login page, I'll create a branch named like front end login, and that's my feature branch. And the rule is you don't touch someone else's branch without permission because you don't want to mess up the state of their work. So related to this, always making sure that your main branch works and runs and the code runs and it's in a good state. If you guys focus on this as a team, everything else will get a whole lot easier. If you want to experiment or try something, you make a separate branch for that. If you want more flexibility, create a branch named dev for development, and you could merge pull requests and stuff onto there. And then every now and then you merge dev to main. But if you follow this rule of don't break the main branch, at 100% of the time, the main branch should run and have the code in a good, sensible state, then your project gets a whole lot easier. And I just want to pause and check in and see if folks have any questions. Carlos, yes, sir.
I'm guessing the only way to make sure that it doesn't break is have a good amount of tests for this, right?
Yeah, exactly. And we'll see this sort of in the feature branch workflow, but the goal is if I'm adding like the front end login page, that I'm doing that on a separate branch. I create a pull request for that, and there's not only tests, but that code has been reviewed by another person. Ideally, they even pull it down and run it. So before we even merge my feature work to main, it's been looked at, all the bugs are resolved on that feature branch, and then we merge it to main. Yeah, great question. We're going to see this a bit more in depth in a minute, but we end up having a sort of like workflow that ends up looking sort of like this, where I might be doing work on my laptop or my local development environment, right? Whatever computer I've got. And then when I'm ready, I push it up to GitHub or the cloud. And I actually have some nicer diagrams of this. And then it's reviewed on the feature branch. When it's been reviewed and approved, it's merged onto main. And then my teammate pulls down main so they have the most recent version of the code that has my feature. And we're going to get into this more in a minute, but this is going to be the sort of basic workflow. And to follow up onto your point, Carlos, the golden rule is like fixing bugs, all those sorts of issues should be done here on this feature branch before you move it to main. So tests are one important part of that, but not the only part. The manual code review is in a lot of ways actually the most important. Yeah, great question. Do folks have any other questions? Other stuff that people are curious about? Okay, cool. Let's keep rolling. So daily stand-ups, this is it's similar to what we've been doing, but with a different goal, more of a sort of true agile stand-up. Um, the goal of this is to communicate, right? Because if I'm working on the front end login page and someone else is working on the back end authentication endpoints, we probably need to communicate and I need to know what the status of that feature is, or if I have a question, or we need to make sure that we're both building stuff the same way. So that's the goal of the stand up. And the goal isn't to have all these discussions in there, but just to identify blockers or questions. And the classic, this is what I did. This is what I'm working on. These are my blockers or questions. And sort of the golden rules of stand up are keep it simple, keep it fast, save the discussions for after the stand up. So if I and the guy working on the backend authentication need to chat, we can do that after the stand up. And you guys can use Slack for stand up too if you don't want to do an actual call. At previous companies I've been at, as someone who likes to talk a lot, I would definitely get feedback after stand up saying, "Hey, like talk less in the stand up to just keep the meeting rolling." So that's really the goal of sort of an agile daily stand up. And you'll find even with 5 people, it actually makes a big difference. So just by communicating like this, it will sort of preemptively help you guys avoid problems and merge conflicts. And do folks have any questions? Okay, cool. So we're going to see the workflow for doing this shortly, but you're going to want to try and take your work and break it into small chunks. Judith's workshop has started with this. We'll see some examples of this in the workshop now. And you're going to want to merge your work to the main branch often. This helps other people keep their code up to date and in sync. And also, the smaller the pull request, the easier it is for someone to review, which is actually a big deal. Like, um, maybe my front end authentication page, just adding the front end routing is probably a little too small, but that's a good example of if all I'm doing is adding an empty skeleton page and a front end route, that code is incredibly easy for someone else to look at and review. This also reduces the risk of merge conflicts and helps us maintain like momentum and velocity as a team. And just fire away or raise your hands if you have questions as I go through this. So related to this, we're going to see this workflow in practice in just a minute. But as you're working on your code, it's not just you working on the code, right? Here on GitHub, we have the main branch, and then we might have someone else's feature branch. And when Bob is done working on his feature, he's going to merge that to main. We're going to have a lot of other people working on features and merging to main, right? 3 or 4 people. So this is going to be happening constantly. So as I'm doing work on my local dev machine over here, and I've got, my feature that I'm working on. And maybe this is a tricky feature. Maybe it's taking me like 2 days to build or something like that. Well, what I want to be doing is whenever a teammate has merged work onto main, I want to be checking out the main branch on my local dev, pulling down the new recent version of main, and merging on my local machine main into my feature branch. So if Bob has finished that backend authentication, I get those changes and I get it here on my local branch. And then if I have merge conflicts or anything like that, this is where I fix them. So any issues that need to be resolved, I'm doing on my feature branch, on my local dev. And if I do this regularly, possibly several times a day, then whatever issues need to be resolved stay small and are pretty easy to fix and aren't going to become a big pain and impact productivity. And I just want to check in and see if folks have questions here or stuff that you're curious about. Cool. And that's the workflow that we're going to demo in just a couple minutes. Next up, you guys are going to want to do code reviews, and we'll see what this looks like. Again, in just a minute, we'll look at an actual pull request. Um, the code review, as to your point, Carlos, really does 2 key things: knowledge sharing and quality assurance. If Bob has written the backend authentication logic, that's something that's probably useful for everyone on the team to know. So if we take a little time now for many, if not all, the people on the team to look at that code, it's going to make all our lives easier moving forward. And then the golden rule of software is humans make mistakes. So you always kind of want multiple eyes on a branch before you merge it to main. And in fact, a lot of companies will set rules in GitHub where GitHub won't let you merge a branch unless it's been approved by at least two people, say. And so this manual code review step really has not been replaced. It's supplemented by tests and all these other features, but it's still a key part. This is also where mentorship can occur when you're a junior engineer at a company. That's really common as well. Your team Slack channel is where pull requests should be posted when they're ready for review, and you should ask a teammate to review it. And this is a normal part of a software engineer's job. And if you look up through Reddit and stuff, you'll see people complaining about how much of their day is spent doing code reviews. And that's true, but it's also a really valuable practice. Identifying work that can be done in parallel. This is of what the team exercise that we have for you guys is going to help with. This is also where a little bit of team planning can go a long way. If I'm working on the front end login pages, whoever is working on the back end authentication, like they can work on that stuff and I can work on that stuff. They're not blocked by me. And while I'm working on the front end login pages, I can create maybe in my front end code, I just fake an API call, or I don't even make the API call, but I return JSON in the correct format with some function. Um, there's a lot of different tactics for doing this. You can make backend what are often called stub endpoints that all they do is return fake data until the real backend logic is done. You can, on the front end, return fake data. So as long as you know the shape of your data, you can pretty much fake it till you make it. Mock data is just another term for like sample data or fake data, same as the fixture data that we use in Django, right? So this is super valuable because the more you can sort of fake data and use mock data and stubs, the more you can do work in parallel. Um, so I just want to pause and see if folks have any questions here or anything on your mind. Okay,
I
cool.
got a quick question. Adam. Do you
Oh
plan on
yeah,
going into
absolutely.
detail about actually doing that?
Unfortunately, not so much. Just in the interest of time of the other things to be covered on this workshop. I will say though, you guys have all seen fixtures, right? And using Django fixtures to put fake data in your database. So creating fake user accounts, I think, is one example. Um, if I'm making an e-commerce platform, maybe I want to fake a shopping cart and load that via a fixture as well. Um, it's almost always like figure out what shape the JSON needs to be that my front end needs to consume and come up with a bit of fake data and either just in my front end code rather than use Axios, just write a function named like fake Axios or something like that, and use it there. There's more sophisticated ways of doing it, but that's the simplest. Or write the actual backend endpoint, like maybe for adding an item to the shopping cart I could write the backend endpoint that my front end is going to call, but maybe the backend doesn't actually call the shopping cart. It just returns some fake JSON. So I apologize. This would be a good one to go into more, but today we're a bit more focused on the Git workflow stuff. Um, the good news here is there is a lot online on this. And if you want to chat more about it later, or like any teams do have questions, I'm happy to chat about it later, one-on-one. Yeah, so that's a good question. Um, and step one here, I think, is just identifying opportunities to use it. And that's part of what I want to emphasize for today is just as you guys are building stuff, just looking for opportunities to fake things. Yeah, good question, Okaino. And again, I'm happy to chat more about it later. Um, Next productivity sort of tip here is some sort of agile sprint. The idea of a sprint is you have, like, say, the classic agile sprint is 2 weeks of work. And before the sprint, you do a planning meeting and you decide what work goes in the sprint, right? And if you have user stories or tasks on a Trello board, like we've started to see with Judas Workshop, then you pull from that, from your backlog. And in theory, you only work on like what you put in the sprint here until you finish everything. Um, and then at the end of this, you do some sort of retro meeting, which is a lot like we've done in class of like what went well, what can we improve. And then you're repeating the cycle here where again you would have your planning meeting. And I think this is really valuable, especially the retro, because it's probably going to be stuff like, oh, like we could have planned XYZ a bit better, or this took a bit longer than we thought. And half the goal here is also just to identify gaps. For you guys on the group project timeline, you might want to think about like a 4-day mini sprint. And the goal here is it kind of lets you set some deadlines but with flexibility, right? Because if we're kind of setting these 4-day mini deadlines, if something ends up taking longer than we need, that's not the end of the world. And that way you can reassess and decide what you need to work on next. I think this can also help in terms of collaboration and as a team and figuring out good ownership of work. Because one week someone, might have to go to the VA a ton because they're out processing. So they might have a light sprint and not a lot of work, but then the next week they might have more availability. Um, so you guys can sort of like play with modifying this format, but I would recommend something along these lines of maybe like thinking of teamwork in 4-day increments. And I just want to see if folks have any questions around this one. Okay, cool. Um, Next up, pair programming. We've done it a lot in class. I know that people tend to have like love-hate reactions to it, so I don't think it's something we need to force, but it's definitely worth thinking about. Um, it can actually help with productivity. Some people find it more enjoyable. It can also help with coming up with a better idea for something the first time around, as well as like sharing knowledge around key parts of the app, like say authentication logic or something. So this one's going to really kind of be up to, the tenor of each individual team. But it's definitely worth considering doing some pair programming on your group projects. Cool. And then this last one I think is actually really, really important. You guys need to pick some roles for your group projects, even if it's informal. And there can be a lot of different roles. You might have someone who does a lot of design work. Maybe if someone is really busy and with their own external commitments and doesn't have a lot of time to write code, maybe they do more QA work or something else. Um, but you're going to want a project leader who sort of sets the vision of the project. Like this is what it should be. Here are the features. It is hopefully motivating people and sort of driving everyone in a lot of ways. Um, but then you also want a manager. And a manager is someone who's keeping track of everything. Who's doing what? Do I need to check in with someone on Slack? If Bob is working on the back end authentication logic and it's taking longer than we thought, and that's slowing Alice down because she's writing something on the front end that really needs it, do we need to like reassign that from Bob to someone else, or should I go chat with Bob? Um, if you guys are using a Trello board, keeping track of the Trello board and other things, um, neither the leader or the manager has to have the strongest technical skills. Sometimes they do, sometimes they don't. Sometimes one person does both roles. Sometimes it's two separate roles. Both can work equally well. I and again, these can be informal. And depending on sort of like the makeup of each team, some teams like them to be more formal, some teams want them to be less formal. But I think it's worth at least briefly discussing these roles and what you guys feel like you need and who's interested in doing them. And I think the golden rule is that um like the folks in the leader or the management roles, and I know a lot of you guys know this, but talking less, listening more, helping people out, and at the end of the day, trying to make the team feel like a team because that helps make it more enjoyable and helps with productivity. So these are the sort of like productivity tactics I wanted to walk over. Um, they really can help with like team flow and help balance the need for accountability without like eliminating like room for autonomy and ownership. So before we wrap this part, I just want to check in and see if folks have any other questions around these sort of tactics. Okay, cool. Um, so the slide deck and then in fact all this written out with a bit more stuff is here in the workshop if you guys want to go back to this. Why don't we take five and then we'll actually demo the feature branch workflow and we'll start to get a little more hands-on with code. Thank you very much, guys, and I'll see you all in 5 minutes. All right. So I talked a lot about these productivity tactics. I just kind of want you guys to file them away as we start to demoing code and you see this stuff in action. And then really the goal of this is that at the end of this, like your team kind of returns to those 10 tactics and like thinks about how we're going to implement them. And I'll also see about finding some good resources to share about faking or stubbing out data, because that was a great question, Okaino, and if we can, actually be good for us to have a bit more resources to share with you guys. Um, so the feature branch workflow is sort of like the standard workflow for collaborating on GitHub. There's other ways of doing it, but this one's been around for a while. So I'm going to talk about it a tiny bit. I'm going to demo it. Then after demoing it, we'll look at some real world examples of pull requests and code review so you guys can kind of see what that looks like. So let's see here. Can we make this bigger? Can you guys see this diagram? Okay. Okay. Awesome. So as I mentioned, this diagram is sort of like the heart of things for the feature branch workflow. If I'm working on a new feature, the first thing I'll do is I've already cloned the repo. I'll check out main on my local dev. So this is me on my local machine, and this is GitHub up here. I'll check out main. I'll pull down main to get the most recent version because, Okaino, maybe you just merged a feature onto main on GitHub, or Nick, maybe you did, and I have to get that work. I'll create my feature branch that I'm going to work on off of main, right? Git checkout space dash B Adams feature branch. I do all my work on my feature branch on local dev. Remember, the goal is to protect main, especially on GitHub. So I never ever want to be dealing with merge conflicts on main. I really don't want to be writing code on main at all because this branch is shared by my team of 5 people. I want to be doing all my work on feature branches. I'm going to be working on my feature. I'm working on my feature. Then I see that, Daniel merged a feature into main because he shared the pull request in Slack and I see it's merged. So on my local branch, I check out main. I run git merge to pull it into my feature branch, and we'll demo this in just a minute. So I now have the most recent version of main here on my feature branch on my local machine. And then when it's ready, I push up my feature branch onto GitHub. I ask for someone to review it by making a pull request. A couple teammates review the pull request, they have feedback, I implement it, I push up the changes, and then on GitHub, we merge the pull request, which merges my feature branch onto the main branch. And so this workflow, right? This is like the basic workflow of collaborating using Git and GitHub. Right? We pull down most recent main. We're going to create our feature branch and write it. We're going to push it and PR it, update it, and approve the PR and merge. And again, I just have the diagram here, but bigger. And while we've got the nice big diagram, actually, let me see if folks have any questions or stuff that you're curious about. Okay, and can I get a quick show of hands? I know we had some exercises earlier in the course that did this. Who's like done this workflow before? So a couple people, and several people not. That's totally fine, and that's exactly what today's for. So let's go ahead and actually demo this. And let's see, can I get this to be, no, it'll take up the full thing. We'll leave it here maybe. So what I've got is this repo here that I've just titled Avenger Git Workshop 2. It's got some empty files from when we were making stuff before, like text files that don't have anything in them. We don't have to worry about those. Um, it's got a little bit of Flask code in this app py file. We're not even going to run the application today. We're just focusing on workflow. But you can see that this is a Flask app. Um, there's a class for a student. We will be modifying this code a bit, so this is good to go over. We see that there's a class for a student. We see we've got a list where we're going to hold all of our student data. And we see here we're manually creating and adding students. I've got a basic sort of hello world endpoint, and I've got an endpoint to return all the different students. And then a little bit of debug information or information of if my app is running in debug mode or not. So this is what we're going to work on modifying. Um, the main branch has some other stuff on it from using this repo before. So for our purposes, we're going to pretend that this branch named main2 is our main branch as we do this work. So let me just sort of like demo this workflow, and Jay, I'm going to ask for a little help just in I'm going to have the world's simplest pull request for you to review and approve in just a minute. So I've got a new task that I want to work on here. And let me give myself a little more room. And sorry, I'm getting a little confused why I can't make an issue. Okay, that's unfortunate and annoying. I apologize, guys. I forked this from a different repo, and it appears that it doesn't want me to make an issue. So I wanted to show that as well, but we'll skip that step. Um, I'll show it here just so we can kind of see what it would look like, even though it won't quite match because it's not for the same repo. But if I'm working on an issue, I might hear or I might say add print statement to students endpoint. And again, this is the world's simplest issue. And so it's just going to be add a hello world print statement to the endpoint. If I wanted sample code here, I could. For more complex issues, you often would to describe it accurately to add to another person. And I'm going to assign this to myself. This issue now has a number. It's number 11. And I'll copy this link and I'll go back before I forget. And so we'll come back to the issue later when we make the pull request here. So now that I'm going to work on this, the first thing I'm going to do is I'm going to make sure I have the most recent version of the main branch, our main two that we're pretending is main. And then I'm going to create a new branch off of it. And I'm going to use the issue number in the name and a brief description of what this feature or this story is. And we're just going to say add print statement. And now I am going to go into my backend code. We're going to add a print statement right here. Let's make it a little more interesting. Let's print the student list. And I think that should work in Python. Do I have that right? I'm not losing my mind.
Comma, yep.
There we go.
Also on line 29, I think it needs
Oh,
all students.
yep, that's a typo. Thank you. And now if I type git status, I see I've modified this file. If I type git diff, I see the changes. So I, in fact, have two separate changes on here. If I wanted to be really strict, I might, in fact, want to do this on a separate feature, but I'm not going to worry about that for now. And I'm going to write a commit message, and we're going to say add print statement, fix breaking typo, add print statement to our endpoint that prints a list of students. Fixed a bad var name typo that would break code. And we'll uncomment these lines so we can see what file is modified. And I'm going to go ahead now and push this up. And now that I've pushed this up, notice that this compare and pull request button has popped up. This is by far the easiest way to create a pull request. Let me show you guys the manual way as well. And the one thing I want to point out about pull requests that's extremely important is creating a pull request is 100% safe. It does not merge anything from one branch to another. It does not change anything at all. It just gives us a way to preview what's going to happen when I do git merge. So the easy way is to hit this compare and pull request button. The manual way is you go here, you hit new pull request. Base is the branch we want to merge onto. So our main two branch. Compare is our feature branch, the one that has the work. So it's going to be this one here. And now I'm going to hit create pull request. Remember, this is completely safe. It is not merging anything. It's just going to give us a space to talk about it and review changes the same way we see this diff between the different branches here. Note that it grabbed my most recent commit message and showed them here, which is great. I'm going to ask Jay to review. That this is your GitHub username, right, Jay? Cruise-J.
Yes, sir.
Awesome. So you're going to be my reviewer. We'll add you as assignee, I think, is the person who has to like merge it. I get a little confused between the two, to be honest. And again, on a practical level, you're probably going to want to use Slack for this. We haven't really talked about labels. Your team definitely can use labels to help organize issues if you want. Um, you don't have to. It's a good practice, but it's not critical. And this would be a new feature or request. You can also create custom labels and stuff. Projects, I wouldn't worry about. Milestones, I wouldn't worry about. Trello's probably honestly a bit easier than GitHub projects to track stuff on. And so now I've got my pull request. This has not merged anything. As it says up here, I want to merge this one commit I made into this branch from my feature branch. Right? So we're now on, if we kind of just hop back real quick to our diagram. Right? I've now pushed up my feature branch code and I'm asking for review. And once the code is reviewed and approved, I will then actually merge it to main. So the rule is I, as the person who created the feature branch, am responsible for pushing this through to get done. And let me drop the pull request link in here in the chat. And if anyone else wants to add comments, go ahead. But Jay, if you could review it, add any comments. If you have any requests for changes you'd like me to make, let me know. And as you guys may know, if you go to files changed here, you can look at and review the different changes. I can add a question here, right? I noticed this typo and decided to fix on this branch, right? All students would break code as it's a bad variable name. And it looks like I forgot part of my markdown. So let's fix that. And so you can add code in here. You can also, if I had multiple commits here, you could review this commit by commit. If there were multiple commits, there would actually be little arrows to jump from one to the next. If someone adds a checklist for me to do, like if someone says, Adam, please do this. If I go over here to checks, oh, I'm sorry, this is a different kind of check. This looks like it's more related to GitHub Actions. But what we should see is we see here the comments, we see the instructions, right? I can check that, uncheck that. Jay says it looks good. Thank you, Jay. Much appreciated. Jay, can you just, oh, did you approve my changes? Perfect. Awesome. So on most engineering teams, they did not actually enforce a rule in the repo where you were required to have multiple reviewers, but that was the rule, and the expectation was that like all the engineers would follow it. So that's what I would recommend starting with. If you guys want to, you indeed can here in settings. If you go to rules, you can add all sorts of rules around branches. Um, you can control modifying to main. You can also, let's see, where is the rule for? There should be a pull request review here. Here we go. Require a pull request before merging, right? So that you can't merge directly to a branch. And I think somewhere on here is require a certain number of approvers as well. So if your team wants to, you can add some rules, or you can just set the rules and expect people to follow them. Both of those I think are appropriate. But I think at minimum, the idea of at least one reviewer before merging is important. As you can tell, GitHub is telling us we should protect the main branch, which is not a bad idea. But so now I've got my pull request. It's been approved. The other good practice is whoever created the pull request should be the person to merge it, right? Like it's my feature, it's my work. I have context on it. I should be the one to sort of have control and flip the switch. Unless I sort of grant that permission to someone else, you generally don't want to do that for someone else. It's going to end up causing confusion and frustration. So when I hit this merge pull request, what it's going to do on GitHub, it's the exact same thing as if here on my local branch, I'm here on main 2. And if I was to do git merge my branch name, right? I'm pulling in the changes from one branch to another. So again, creating the pull request did not do anything. And to kind of go back to our diagram here, right? I branched off of main. I did my feature branch work. I pushed it up. It was reviewed. If I had changes that I need to make, I would change them and push them up. And now that it's approved, when I click that merge button, now it will actually on GitHub in the cloud run git merge to merge this branch onto the main branch. And if I wanted to add more of a commit message here, I could, but that's really all I need to do. We'll give it a minute. It's merged. I'll go ahead and I'll also delete that branch. I don't really need it anymore unless I know I'm going to do more work on it. The branch is now gone, but we have the pull request here in history. And often you will go back and look at previous pull requests to see things. And now the main branch has the change. And so I would maybe put out a message in our team Slack channel telling everyone, hey, like this change was merged and I now run git pull. So now on my local machine, I have the updated version of main. So I just want to pause and check in here and see what questions folks have around this workflow. And this is sort of like the basic workflow that you guys will be doing all the time. Nick, yes, sir.
Say you and Jay were working and you just did this. I am
Yep.
working on a completely different branch.
Yep.
How do I pull in y'all's changes to my uh branch that I'm working on? Is it just can I just do git pull?
Right. Great question. Let me go ahead and demo that real quick. Let's create a branch and let's just call it like Adam's feature branch. And let's say I'm doing some work here. Um, and let's say I, I don't know, I'm adding like another student. And, maybe I'm adding a print statement and whatever. And I haven't committed this code yet, and I don't quite want to yet. And I see in Slack, hey, Adam just merged his other feature to the main branch. So what I'm gonna do is um I could commit my work. This is in a lot of ways the easiest way to do it, to be honest, and just call this a work in progress commit. Um, what you could also do, right? I now have my work that's not added. There's a really nifty command git stash, and that takes any uncommitted changes and it saves them somewhere. Git puts them in a file somewhere. And it's actually a little stack data structure. And then if I run git stash pop, I get those changes back. So often what I would do is I would do git stash, right? Because now my feature branch is clean. There's nothing unstaged or added. Everything is committed. I would check out the main branch. Let's pretend that there was a change here I didn't have. I would pull it down. I would check out my feature branch. And then here on my local dev, I would do git merge main onto my feature branch. And in fact, I forgot to use the main two branch name. So let's undo this. Let's do git merge abort. We'll talk about that in a bit with merge conflicts. Right. So again, on my local branch, we've got main over here and my feature branch over here. And I'll just name this main two since that's the one we're using. So Nick, you're doing work, you're doing work. You know, Daniel has finished a feature on main. You get your feature branch in a clean state, whether you use git stash or you just commit your work. On your local machine, you check out main, you pull down the work from Daniel, you pull down the most recent main, you hop back over to your feature branch, and then you merge, right? So it's like git check out main, git pull, git check out my feature branch, and then I merge main onto my feature branch. Now, if there's a merge conflict with Daniel's work, we're going to see that in just a little bit, how to fix that. But a lot of the time there won't be, right? If he's working on code that is not in the same area as your code, there's not going to be a merge conflict. A merge conflict really only happens if like two people have modified the same bit of code and can't figure it out. And so then you have the most recent changes from main now merged onto your feature branch on your local machine. And if I use git stash, I can just do git stash pop to bring my work back and continue working. Does that help answer your question, Nick?
Yes, sir.
Yeah, great question. Alex, yes, sir.
So if you commit it as a work in progress and then that's basically to save in case there are conflicts kind of thing. And does it do the same thing as the git stash?
Two different things. What git stash will do is git stash is when I have work that I'm not ready to commit, but I want to just temporarily save it somewhere. Um, like with git stash, like it takes that uncommitted work and it saves it in some little file somewhere or something. I can actually use that anywhere. Like if I do git stash pop, I will get that stashed work on a different branch. Now, it doesn't make a lot of sense in this context, but sometimes that's useful. So it's kind of like I imagine like if I'm working at my desk and I just need to make a little room temporarily, I might like stick the papers that I'm working on in a folder. That's git stash. And then whenever I'm ready to put that work back on my desk, I do git stash pop.
And if you didn't do that, it would overwrite your work, right? You lose what you were working on if you weren't to use git stash or git commit before.
Potentially, or a merge conflict, or I'm not even, I think it lets you merge if you have uncommitted work, but I honestly don't remember. I just try to avoid it. Just in general, before you're like merging from one branch to another, it's just really nice to have both the branches be clean, right? To avoid potential issues. And also, you guys saw, um, I goofed earlier and I merged the wrong branch. I think I did git merge main, right? Instead of the main dash two. And in fact, we see this message here, error, your local changes to the following files would be overridden. Please commit your changes or stash them before you merge. So Git won't even let me merge them. So that's where I can do git stash. Or if instead I know I want to keep this work, but maybe I'm gonna squash the commits later, or I just don't have a good name for that commit message, I might just commit it. And WIP is just short for work in progress. So if someone else sees that on a commit, they'll know that like the state of the code captured in this commit isn't 100% done. It's a work in progress commit.
So if you did all your work on file A and then you stash it and then somebody creates a file B, when you pull it, when you pop the stash, would it delete that file? Would it delete file B, or would it just revert file A to what you had stashed it before, assuming that there were some changes?
Yeah, that's a good question. Let's demo that real quick right now, in fact. Um, let's just make a file, a my file.txt. Oh, did we have, I think we had the file committed. Now let's go ahead, let's add another print statement. This might not be exactly what you were saying, but so git stash. Remember, a commit tracks like individual changes within a file. So if I type git status right now, I see I've modified these two files. If I type git diff, we see the actual changes, like the specific lines that have been changed on the files in question. If I do git stash, it takes those specific changes to those bits of the files and puts it in a folder. And if I do git stash pop, it's just adding them back, right? So it's this print statement right here, this print statement right here, and then this line here, right? So it's very specific, right? It's about changes to files, which could include adding a new file, like if I did touch yet another file.txt, right? If I type git status, that's an untracked file. Let's see if git stash grabs it. So Git isn't even tracking this new file yet, because I haven't added it. So that's a little bit of a difference with creating files with Git. And if we do git status, we see we have the untracked file. And if I do git stash pop, we see the untracked file is unaffected and it's only those specific changes. So git stash is never going to delete anything. It's only going to add back in whatever we put there. Again, if you think about the metaphor of like, I have some papers on my desk, I put them in a drawer. When I put the papers back on my desk, they're just going on top of whatever other papers are there. Does that help answer your question?
Yeah, thank you.
Yeah, great question. What else is on people's minds? What other questions do folks have? And again, this is sort of the basic workflow that you guys will be doing all the time. So let's and you can definitely, the slide deck is here for you guys to look at if it's useful to pull it up. And again, if you kind of just, I think, remember it as like a cycle, I think it helps a lot. And the one thing I think that's a little novel for us to get used to is running git merge locally, right? But again, the idea is protect the main branch, do all my work on my feature branch, and I want to do it all locally. I don't want to have to like mess with the GitHub web editor to try and deal with my feature branch on the GitHub repo. And that's why we merge from main onto my feature branch, so that if there is a merge conflict or an issue, we're fixing it on the feature branch, even on my local machine and not on main. So let me show you guys a couple real world examples of code reviews and pull requests. And then we'll take a break and then we'll demo merge conflicts. Sound good? Cool. And then after the merge conflict demo, that's really the last part of the workshop. And then I have the exercise for you guys to do. So we're making good time here. So let me go ahead and let's full screen this real quick. Oh, and that actually that does work. Actually, that's what I wanted earlier. So these are really similar to these sort of team productivity tactics that we saw before. Um, don't have two people touch the same code at the same time. Never modify someone else's feature branch without their permission. Do all of your work on a feature branch. Always resolve merge conflicts locally on the feature branch. And if you are dealing with a merge conflict, meant get the person who wrote the code that your code conflicted with to look at the PR, right? Like if I'm dealing with a merge conflict and it involves some code that you worked on, Nick, I should get your eyes on it to make sure I haven't messed something up without realizing it. So again, I think these can be a little abstract now, but I would definitely come back to these as you guys get deeper into your group project. We've seen pull requests. Let's look at a couple real world examples. This is actually from Django's open source project. And it looks like this is some sort of bug fix. And you can see this is I didn't demo this in ours, and I should have, but if I go back to my closed pull request and I edit the message, what I should have said here is resolves. It doesn't let me, if I hadn't forked this, I could do pound and the issue number, and then this would link. Oh, there we go. A link to the issue. Right? So that's a good habit and a good reason to build issues. And then if we go over here, we can see that this issue was mentioned on this pull request that was merged. So we can sort of track and see the status of things. So looking at like a real pull request on the Django open source project, we can see the same thing. They're using a ticketing system, in fact, so it's not GitHub issues, but they have a pretty rich description of the task. You can see here they put the error message. They've put quite a lot of descriptive information for whomever is going to tackle this. And then there's a bunch of discussion around it. You can see here a description of the work done. This checklist must be about the sort of Django project's policies. And then you can see here what code review sort of looks like, where you see a pretty rich conversation happening here. Someone saying this looks good, but it needs to have tests to be accepted. They must not have written tests the first time around. That's pretty normal. Every job I was ever at, if my pull request didn't have tests for any code I'd added, it wasn't even going to be looked at. They wouldn't waste their time. Notice how someone's asking a pretty specific question around the code here to try and understand like what's going on, or like should this be included in this feature or a different one. It looks like this is the person doing the work. The sort of more senior engineer is saying do it as a part of this. And then finally, they get the thumbs up, the approval, the happy rocket. Someone else here is happy. And then this pull request got merged. If we take a look at another this is actually from the React project. Again, we'll see something really similar. Here, because this is a front-end feature, they have actually included a video so that whomever is reviewing this can see like the UI work done. And this task was to modify Chrome DevTools, I think. And they have a description here. They're adding a sidebar to some Chrome DevTools tag. They have instructions on how to test it, which is really normal for a pull request. Giving the reviewer instructions like how to run the project and test the code. We can see here there was a GitHub issue related to this. And there's, again, a pretty rich description of the task, a pretty rich description of what they want, a screenshot, some checkboxes. So again, you can see here how like remote collaboration is kind of a first-class citizen, and writing good issues and pull requests is a big deal. I also want to point out for your guys' group projects, in a lot of ways, because you'll want to make your repos for your group projects public, this all sort of becomes a part of your portfolio, right? So if I'm an engineer looking at your group project portfolio, if I'm seeing like issues with good descriptions and screenshots and pull requests and all that, that's only going to be a plus, right? So I would just encourage you all to think about it that way. You can see here instructions on how to test the change. You can see here there's actually some design feedback, a question. Um, Someone else is saying, hey, that's a good design suggestion, but let's not block on this, as they call it, a nitpick. But maybe we have that become a separate feature. So again, code review is more than just QA. It's about discussing code and features and stuff. And someone saying, yeah, no, we'll just do it this way, whatever, whatever. And then this is merged and reviewed. And if we look at the code changed, this is actually it touches a lot of different files. So this is actually a pretty large pull request. Like you kind of want pull requests to be as small as possible. And this is actually a pretty big one. And you can see here that while the change to each individual file is small, a lot of files needed to be modified to implement this feature. And so you can see how this is really useful for managing a team in a larger project. So what makes a good pull request and a good pull request message? Um, as I mentioned, the smaller the better, easier to review, easier to look at, easier to merge, less merge conflicts. The code's got to work. This sounds obvious, but it bears repeating. If I have a pull request, all the merge conflicts should be fixed beforehand. The title should make sense. It should have a link to the GitHub issue or the Trello card. It needs a description of what this pull request is doing. Um, Links to code in GitHub or markdown examples, making it easy for the reviewer to use as possible. This part's really important. Instructions for the reviewer. If a new dependency's been added and they need to run install steps, if there's a new model and they need to create migrations, that should be mentioned. So when I'm reviewing the PR, I don't have to dig and think about this stuff. The person writing this has done this all for me. If it's a front end one, UI screenshots, if there's relevant diagrams, and then tagging relevant collaborators. So this is sort of a high watermark for your group projects, right? You guys may not do all of this, but I at least want to like set the expectation of when you first join an engineering team and you're on the job, what your pull requests will have to look like, because all this is pretty standard. If you guys do this on your group projects, that will be amazing and make it for a great portfolio. So as long as it doesn't slow you down too much, I would encourage you to. We already looked at these, so we can kind of skip over that. I already talked about code reviews, but I grabbed some examples here. If you guys want to look at this later, you can see that there's a lot of back and forth discussion that happens as part of a code review on a PR. As I mentioned, code reviews have a lot of goals. Catching human error is a big one. QA is a big one. It's used to enforce best practices, right? Code patterns, naming conventions, style. Mentorship and knowledge sharing happens a lot through pull requests, and design discussion also happens through pull requests. So this is why I'm really encouraging you guys to pull request and review everything, because it's not just about QA. It really is about these other things, as you can see from these real world projects. That is it, gentlemen. Yes, sir. Alex.
Is there a good way to see if the code runs without having the other person just run it on their local environment? Or do you just take their word that it runs?
Yeah, that's a good question. So that's where having a test suite helps a lot. We haven't really gotten into GitHub Actions, but you can do stuff like uh, the same way our assessments use GitHub Actions actually, where every time you push, it runs tests. So you could set that up so that if you had tests, GitHub Actions would run them and you don't merge a pull request until it passes the tests. But No, like in a perfect world, if I'm reviewing your code, Alex, I should actually pull down your branch and run it locally to make sure it works and then give it the thumbs up. You are correct, though. A lot of this is taken on trust. And that's where, even as a junior software engineer, you have a relatively high level of responsibility. Where, like, if someone asks you, hey, does this code run? And it works, if you say yes, they're gonna trust you, right? So even for small features, and even as a junior dev, it's important to do a lot of dotting your I's and crossing your T's, because high performing engineering teams tend to run on trust. And so building and maintaining that trust is an important task, which all of you will excel at. Does that help answer your question?
Yeah, thank you.
Yeah, great question. Andy, yes, sir.
When writing tests, I noticed that they're asking if you wrote your own test for it. Uh, that kind of seems like there's some trust reliance there as well, as in like how did you make the test to make sure that your code passes your specific test, or are you following what I'm trying to say? It's like there's no didn't someone else didn't create that test, you created that test for your own code.
Yeah, exactly. You're absolutely right. There's a lot of trust happening there as well. Now, as a junior engineer joining a company, if I'm writing a test, my code reviews are going to get a lot of attention early on, both for mentorship reasons and, as you pointed out, for the trust reasons. So, those tests will be looked at. And in that particular Django PR, let's see if we can go back to find it. I think it was this one here. And somewhere in here they mentioned, yeah, they mentioned that tests are needed here. So at some point, once the tests were added, um, probably here, this person, the more sort of senior reviewer, went back and looked at it again and gave it a thumbs up. Um, so ideally, the tests are reviewed, right? We can see the tests here. And this is a big part of the job of a senior engineer, is just reviewing tests. And in fact, this looks very similar to what we saw in our OPA assessment. We have a mock here with a patch. We have an assertion test. Um, but you're absolutely correct that at the end of the day, there's still like a high level of trust. And that's just, I think, how most software engineering teams function. That said, because there is going to be code review in QA, I think if someone was not doing a very good job writing code on a good team, that would be noticed pretty quickly and mentioned to them. And then they would be mentored on that, if that makes sense. So that, especially for junior engineers, like, people are expecting you guys to not know this stuff and to get parts of it wrong and to be mentored. But then, they're expecting you to get it right like the second or third time around. And then if it became a sustained issue, then like that would become its own issue. But you guys aren't going to have to worry about that, to be honest. But yeah, even for junior software engineers, there's just a really high level of ownership and trust that's expected, which is both good and bad, right? But also why this is a good profession to be in. Also, why you see a lot of conflicting feelings around AI generated code. I've in fact started to see prior attribution of AI code in pull requests. Let's see if we can find this. I am starting to see, I saw an article in Hacker News about this. Um, I'm starting to see teams getting frustrated with large amounts of AI generated code, not because it's AI generated, but because if the code's not very good or there's just a ton of it, like, you lose that step of the junior engineer has put in that time, sweat, and effort, and that trust factor of a human has looked over that code and is vouching for it, right? When I submit my code for code review, the expectation is I've put in the time and the sweat to make sure the code is correct, that it's following our standards, that it's the best that I can make it. as appropriate. So there are starting to become evolving standards for disclosing AI involvement. And this is not about like GitHub Copilot helping with a little bit of autocomplete. This is like people who are writing big, markdown files and having like AI generate like hundreds of lines of code all in one go. This is not about the sort of autocomplete on steroids. This is about like massive amounts of code where there's like less so like a human in the loop. Um, and as you can see here, again, they're saying, hey, I want like human manual verification of my code. I don't just want a bunch of code that assumes the AI is correct. I only started learning about this stuff last week, so I think this stuff is fairly new, but I think this is only going to evolve and grow as time goes on. Because as you point out, Andy, a lot of the value we provide as software engineers is like we're vouching for our work and that we've looked over it and reviewed it. And there's a lot of value in that. Yeah, great question. Did someone else have a question as well? And I see a comment too in the chat. Okano, you were saying, I don't think any of us have to do all of this by yourselves, including writing the tests. Um, and
What
I
I'm
think,
saying is that we can,
yeah, please.
yeah, we could definitely trust each other, but we could definitely help each other like in every step of the way. Even
Yeah,
if it seems like something simple and small,
yeah, a
like we
hundred
don't have to
percent,
be an island unto ourselves.
100%. Yes, that's an excellent point. Yeah, you absolutely don't have to do all this by yourselves. You guys should be helping each other. You can be learning this stuff right now. Um, And, even as a junior dev at a company, there's mentorship and support in doing these. And some of these, like the really robust, like descriptions and pull requests with screenshots and stuff, it can be kind of up to you guys how much of that you want to take on. Because the reality is this does add extra time, right? And this isn't like a skill you learn overnight. And this is also why, as a junior software engineer for my first couple months, I'm probably given really small learning tasks because it's as much about kind of getting used to this workflow and learning this stuff as writing the code itself. So that I think that's a really good point, Okaido. Um, yeah, the expectation isn't that you master this all by yourself immediately. Um, and open source projects in particular tend to be pretty, like not every company is this good. Trust me, there's a lot of places not nearly this good, but the big open source projects tend to be really good about their code review practices and stuff. So this is a good high water mark. And yeah, and you don't have to figure it out all on your own. All right, why don't we take 10, gentlemen? And then when we come back, we can demo Jay, with your help, will cause a merge conflict. I'll show you guys how to resolve the merge conflict in VS Code with VS Code's, it's called a diff tool. And then that'll be our sort of last part of the workshop. And then I have an exercise for you guys. Okay, awesome, guys. Thank you very much. And I'll see you all in 10 minutes. All right, we are now going to talk about merge conflicts. And again, this is in the this Git workshop repo that's in our curriculum org. If you want to refer back to it later, I'm going to do a little bit of talking about what causes merge conflicts, how to fix them, a little bit about prevention. We've kind of already talked about it. And then with some help, I'll demo causing a merge conflict and fixing it. So we're going to talk a little bit about what happens when Git performs a merge and then what causes merge conflicts. This is important because software development is a team sport and you don't really encounter merge conflicts when you're writing code all by yourself. But you absolutely do when you're writing code on a team. And to a degree, a merge conflict is normal because you're constantly bringing in the main branch to your feature branch, right? Like, Andy, once you finish your feature and merge it to main, I'll see in Slack that you did that. So on my local machine, I'll check out main, I'll pull it down, I'll get your changes, And then on my local machine, I'll merge main into my own branch. And sometimes merge conflicts happen there for perfectly legitimate reasons, and then I got to fix them. So when I run merge, there's two ways that Git combines matches. One is called a fast forward merge. The other is a three-way merge. These are what's called merge strategies. We're not going to get too deep into this. Git automatically will choose a merge strategy. You almost never need to manually choose one. And if you are manually choosing a merge strategy, something probably has gone wrong. So this is more of an FYI. There is some jargon here worth mentioning. Current branch is the branch I currently have checked out and I'm working on, right? So right now, my current branch is Adam's feature branch. The target branch is if I run git merge on my current branch, the target branch is the branch we're going to merge into it. So if I was to do git merge main, main would be the target branch, and I'm merging main onto my feature branch. Note, and to go back to the diagram I love of we have the cloud, even though I realize this almost looks like a smiley face, and we have local dev. And we have, you know, main, and we have my feature branch. Note how when I'm doing work locally, like Andy, you've done some work and merged it onto main. Well, I've gone ahead and pulled down that work and I'm merging main onto my feature branch on my local machine. But then when my work on my feature branch is done and I push it up, once everything is good to go on GitHub, we're merging my feature branch onto main. So I just want to point that out. For local dev, we're merging main onto my feature branch. I'm pulling in other people's work onto the branch where I'm doing work. But then I push that work up to GitHub. And when the pull request has been approved, we're merging from my feature branch onto the main branch on GitHub. So current branch is the branch that's checked out. Target branch is the branch we're merging into the current branch. There's also a term called common base. This is less important, but it's good to be aware of. This is the most recent commit shared by two branches. Sometimes it's also called the common ancestor. And then tip is the most recent commit on a branch. This is also called head. So if I'm doing work on my branch and I want to merge that work into main, I would check out main, right? And then when I run get merge, main is my current branch and my feature branch is my target branch. I'm not going to dive into this too much. Sometimes there's an easy way to merge. If there's a direct path from the current branch to the target branch, Git does what it calls a fast forward merge. If we look at this here on my feature branch, I have work done, right? I've done some commits. Here's the most recent commit on my feature branch. Here's where they shared work, and then I branched off as I was doing work. And there's really no other changes here on main. So merging this in becomes easy, right? Main has not been changed since we made the feature branch. All the new commits are what we call ahead of main. Git really just moves the pointer for main forward, and it doesn't even make a merge commit. The other kind of merge is what's called a three-way merge, and this is where we do have commits since the branch was created. We have a common ancestor here. I branched off, I did work, I did more work, I did more work, but someone else has merged their feature branch onto main, and there's some work here, and there's some work here. And so now Git is going to create a merge commit that sort of combines changes from both branches. Um, and this merge commit actually has two parent commits, one from each branch. So this commit points back here and here. We don't have to worry about this too much, but I did want to just introduce these and at least walk through them a little bit. Git will automatically choose the merge strategy. And a lot of the times it is doing a three-way merge because this is what happens when the main branch has diverged, which is pretty common. Now, as you can probably guess, it's when the main branch has diverged that we have merge conflicts, right? So a merge conflict is actually a good thing in that Git does not try to be too smart. It's really good about not being too smart, and that's what we want. We don't want Git to make too many decisions for us. Sometimes Git can figure out how to automatically combine changes, but sometimes it can't. Usually it's because the same line of code has been changed. Uppercase directory names or different cases for directory names. If we're adding files, if we're moving directories around, if there's structural changes, if a branch has not been touched in ages and there's just a zillion changes from main to merge in, all of these can cause merge conflicts. A simple example is two developers modifying the same line of code. Git can't automatically figure out which version should be kept. Uppercase directory names. So this is more of a gotcha. On Mac, by default, the file system is set not to be case sensitive. So it ignores like case sensitivity for directories and file names. And this is from experience with a previous cohorts group project. On Linux, though, like say Ubuntu or whatever version of Linux GitHub is running, the file system is case sensitive. So if one teammate has Linux and another has Mac, if I have like a directory name with uppercase, but then someone else has it lowercase, this can be a huge pain. So it's really important to have a consistent naming convention. I would just avoid case sensitive directory names. Make sure everyone on the team is following the exact same naming convention for what you uppercase and lowercase and file names. There's best practices for React and Django, so you should follow those. Have everyone name everything the same way. These other ones I'm not going to get into too much. So I think the best thing for us is to get to the demo. I do want to point out a couple good practices on avoiding merge conflicts. We've talked about this. This sort of comes from the teamwork tactics slideshow at the beginning. Communication is the big one. Don't touch the same parts of the code at the same time. Do small features, right? The smaller the feature, the quicker you can review it, the quicker you can merge it. Make sure everyone on the team is on board with naming and style conventions and organizing code and have everyone do it the same way. You guys should be using linters. Use Prettier and ESLint for front-end JavaScript stuff. Use Black or AutoPep8 for Python stuff. So I just want to point out a little bit of the impact that like good code organization can have. If I'm organizing some front-end code, and let's say I have a directory for, let's call them services, and there's a file for API stuff, for authentication, and for validation logic. This means that if one person is working on API and another is working on auth stuff, it's two separate files, right? So we don't have two people interacting with the same file. If, on the other hand, we just have all of that stuff crammed into a utils.js file, then it increases the chance of two people maybe interacting with the same code or causing a merge conflict or some confusion in some way, right? And so this is a simple example, but I think this is a good example of where like small, separation of concerns can be useful. So I've kind of gone over these conclusions many times. So I just want to pause and see if folks have any questions before we switch gears and demo. Okay. Alex, yes, sir.
What's the best practice for sharing the hidden files, such as like where you store the API key and stuff?
Oh, like dot files and stuff?
Yeah.
Yeah. So let's just talk specifically .env files. Um, best practice is really two things. Make a .env example file. And in fact, I have one here already. And this is really how I can document for other developers what environment variables need to be here. And then to be honest, like for an API key, maybe just share it over Slack. Um, there is something called GitHub Secrets, but that's more for CI/CD or a lot of places I've been at, they use the password manager like LastPass, and that's where they would put like API keys. And so when I joined, I would, get a LastPass membership and the actual API key would be there. I think for you guys, the simple way is make a .env .example file, and it's okay to send an API key in Slack and then just delete the Slack message. GitHub Secrets is going to be a bit overkill and more for CI/CD. LastPass is probably too much friction and too much headache, but those would be the sort of real world ways of dealing with those. Does that help answer your question?
Yeah. Thank you.
Yeah, good question. Totally. Yeah, GitHub Secrets. I'll show you guys real quick. So I think if we go here to settings, and then we go to secrets and variables. So I have not, full disclosure, played around a lot with GitHub Secrets. It's really more of a GitHub Actions thing, where if I'm writing a GitHub Actions script that say runs npm build and then sends that to an AWS EC2, I could add an API key here. So if you guys wanted to, you could put them here just for sort of documentary purposes, and then people could go, they'd have to join the repo and then they could go look at it. But for the group project, I don't think that's a deal breaker. All right, let's talk about some code modifications and causing a merge conflict. And so, and let me pull up my guide here as the steps here. I do have to be a little careful. And in fact, let me just pull this up here because it'll be helpful, I think, to see this. So here's what we're going to do to cause a merge conflict. We're going to make two different GitHub issues. Jay and I will write some code. Jay, you're going to make a pull request. We're going to merge it onto main. I'm going to then pull request my code. We're going to see a conflict. We'll explain the cause of the conflict and look at the PR diff. I'll show how to fix the merge conflict locally on my computer and what that workflow looks like so that so main is always in a good state. So Jay, if you don't mind, just let me create an issue for you now, in fact. And so we have one here, in fact, and let me drop this into the Zoom chat. And so if you don't mind, maybe just make a branch off of the main -2 branch that has, this issue number in there. And then this is going to be your task. And let me go ahead and put this here and give me a moment to exit full screen, gentlemen. My apologies. And we can see what this work is. So what this task is there's a get students endpoint. And we want to add a query param, so it should accept an ID. And there's some code that I put in here because the purpose of this is not writing code, it's creating a merge conflict that you can use to grab the ID from the HTTP request and then grab the student. So I'd like you to do both of those things. Then I'd like you to rename this all students variable to something else. And then I'd like you to give each student here, like Harry, Hermione, Ron, Bob, Carol, give them a different name. And I'd like you to do this all on that one branch and most importantly in one single commit, because that's what's going to guarantee us to have a merge conflict. Jay, does that make sense?
Yep, too easy.
Awesome. And when you're ready, just push that code up and make a pull request and let me know. And while you're doing that, what I am going to do, and let me go ahead and check out let's do git restore star. Let me just quickly clean up these changes that we don't need or care about. So as Jay's working on his feature, I'm working on mine. We have our pretend main branch. I've pulled it down. It doesn't have any of Jay's work, right? But I'm going to branch off of it. I'm going to make a new branch, and this is my feature branch. And here, my task is going to be, I'm going to move the all students dictionary into a separate file. And I'm going to move this student class into a separate file as well. Because that's good code organization, right? This should be in its own file. This should be in its own file. Now I'll have to make some changes to this code. But then this work is definitely going to cause a conflict with Jay's work, and that's what we're going to see in a minute. So I'm going to go ahead and let's make a file named students.py. And we're going to take this class and we're going to put it here. And we're going to import it. And now I need to take the all students dictionary and move it into a separate file. And that's actually a pretty big refactor. Depending, I guess, on if I like move this data here as well. And I think I will, because that kind of makes sense. Like this is a little clunky. Let's make a file named all students. And what I'll do is I'm just going to copy all of this. I'm going to paste it in here. And in fact, what I'm going to do is we're not going to like append all this stuff like this. We're just going to insert it. And now I want to make sure I've done this correct. And I do have to import my student class. And now over here, I don't want this stuff. What I want to do is from all students, import all students. And now I don't even need this import statement here. And so this is my work. And let me full screen this and double check. And let's go back to here. Let's look at all students. If I do get diff, we see there's a bunch of changes. Things have been moved, things have been deleted. I have some untracked files. Let's go ahead and add everything. Let's go ahead and commit. And we'll call this move all students, student to separate files. Move all students sticked to a separate file. Refactor it, right? Move student class. And I'm going to push that code up. And let me hop over to my repo. And I do have to make sure I get to the right spot here because I have a bunch of different things open. And here we go. So here's this file that I was just working on. And let's make a pull request for it. And I'll just say move student dict. And remember, creating a pull request does not merge anything. Right. And so we now have, let me make sure I made the pull request in the right spot. I apologize, guys. Give me a moment here. So I think I made it in the wrong spot because of the forking. Sorry for the confusion. Let's make that real quick right now. If I go to pull requests and I do a new pull request, there's my change. There's the main branch. That ought to do it. Let's make sure this is what we want. And this is what I was expecting. And if we look here, we see I've created this file. I've added this stuff, right? I've moved this and I've gotten rid of all this. Jay, how's it going on your end?
Yeah, all changes have been made, but I'm getting error when I push the branch right access to repo not granted.
Oh, I may need to add you as a collaborator. Let me see if I can't just take care of that right now. Give me 1 second. Sorry about that. I think I forgot about that one. And let's go ahead and let's add you as a collaborator. Is your GitHub name J dash?
No, you had it right. The one with the pigeon profile.
And this one, correct?
Yep.
Okay, perfect. And we're going to give you right access and add you. And let's see, are you able to go ahead and push it up now and open the PR?
Yep. Let me just make a PR.
Awesome. No sweat. Yeah. And so what we're going to do here, folks, is as you can probably imagine, these two issues touch the same code in a number of ways, and it's going to cause a conflict. So once Jay's code is pushed up, and again, sorry for not giving you right access earlier, we'll merge that to main, and then we'll see how that causes a merge conflict on my branch, which isn't yet merged, and how to resolve it. And let me know when you've made the PR, and you may have to be a little careful because I forked it a bit. Like I did something I think a little silly there. To make sure that the PR is on the Avenger Git Workshop 2 branch and not its upstream fork of Zulu Git Workshop.
Yeah, I pushed it.
Okay, awesome. Um, can you go ahead and make a pull request?
Okay, done. I'm getting a branch has conflict, must be resolved.
You're getting a a what?
A branch has conflicts, it must be resolved.
Oh, uh-oh, you're getting it on your end. All right, let me make that same pull request so we can see it here as long as I'm screen sharing. So let's see. Is J Features, is that your branch?
Yes, sir.
All right, let's see. Maybe we have a different merge conflict and maybe we just fix that one instead.
But I think you're right. I think it pushed it to um
Oh,
the fork of Zulu Git Workshop.
yeah. And I forgot to do this too. We have to use the main two branch, which is a little annoying. Um, and in fact, let me modify my pull request as well to do that, and then we can circle back. Um, next time we'll have to make a template or something for this to avoid that. That's too much of a gotcha. So now I think it works. It must have been one of those two issues. Um, let's take a look at Jay's changes. They look great, right? All of Jay's students append. You've changed all the names. Our route, we have a goodbye route now, which is great. Um, let's see here. Was there the change to? I don't see the change to get a student by ID, but that's okay. I think we'll still see a number of conflicts. Um, I think the issue had like adding some code here so that when I get a student, I can get a student by ID or adding, but I think we'll still see conflicts here, so we should be good to go. Jay, let me go ahead and thumbs up your feature, and I'll just say like looks good to me. And do you want to go ahead and merge it?
Yes, sir.
All right. And let me know when it's merged.
I'm not seeing any updates.
Oh, okay. I think I'll merge it just in the interest of time as I have it pulled up here. So I do apologize for that. And thank you for being flexible with me merging your PR, which normally we want to avoid. But we've got Jay's features merged in here. And now if we go back to my features, we now see this branch has conflicts that must be resolved. Right? And this is what we wanted to see. Now there is this resolve conflicts button, and it gives you a web editor to do stuff. You really want to avoid this. It's going to be a little too painful and difficult. And as merge conflicts get more complicated, you're not going to want to do it. If I look here at files changed, actually, my apologies. If we go here and we look in the conversation, we see a hint about where the merge conflict is. So now that we've caused the merge conflict, let's see how to resolve it on VS Code. So let me go ahead and pull up VS Code. And Jay, thank you. I realized too, like sort of like negotiating these steps over Zoom is a little tricky. So I've got my feature branch here. Let's check out that main branch. Let me pull down the changes. And here we have Jay's work, right? And so far, so good. What I'm going to do now, though, is I'm going to go back to my feature branch and I'm going to merge main onto my feature branch, right? And this is going to cause that same merge conflict that we saw the pull request hinting about on my local machine, and we'll then resolve it. So we see it tries to auto merge, it can't. It says there's a merge conflict, fix conflicts, then commit the results. So let's see how we do this. And let me go ahead and just close out some of these files. And so here, there's a couple ways to see the merge conflicts. One way is if you go to the version control tool. If I can find it in here, my apologies. I have like 1,000 different extensions. There it is. We can sort of see where a merge conflict is, but honestly, looking at the command line input here is probably the easiest way to do it, and is normally how I do it. Note this resolve and merge editor button here, and that's what we're going to use in just a second. But let me show you guys what a merge conflict is. So there's these options here: accept current change, accept incoming change, accept both changes, compare changes. You can use this, and once you get more experienced with it, this can make simple merge conflicts easier. But this merge editor is going to give us a much more powerful comparison tool. But the main thing is note that this is just text. Like VS Code has added some colors here, but we see like these arrows and it says head and it's current change. And we see main to incoming change. And what we see is here in blue, we see Jay's changes, right? All of Jay's students, Dumbledore, Snape, so on. And by the way, if I just like deleted this stuff, note how VS Code doesn't really realize there's a merge conflict here anymore. Let's see here. I want to bring it back. I may struggle a bit here to bring it back. And in fact, now that I've screwed this up, let's do git merge aborts. And let's run the merge again. And we have the same thing going on. And let's open up app PY. And let's actually click on this resolve
You want
merge
to merge the
editor.
main too?
Oh, thank you so much. Yep, I knew that was going to get me. There we go. And so let's take a look at this merge editor. Thank you so much. So this looks like a lot at first glance, right? What we have here on the left is the target branch, the incoming changes. That's coming from, in this case, from the main to branch that I'm merging in. What we have here on the right is my current branch, which is my feature branch. And what we have in the middle is the merge of the two. So if we look at this from the top down, we see over here from main branch with J's changes, it doesn't have this all students import all students because we didn't move that to a separate file. But we have that over here on the right from my branch. And in the proposed merge here in the middle, we have that added. So the thing about resolving a merge conflict is you have to really understand what the code is doing and why. And so you often might need to talk to the other person involved with the code that yours is conflicting with, because we're going to have to do some inference here. And I know that I want to end up in a scenario where I still have all the students in a separate file. So I am going to leave that line here. As we keep going, we see the next big change is this student class, where it's gone and deleted from my current branch because I moved it into a separate file. But on J's branch that got merged into main, it's still there, right? And so this is where we have the conflict because we have a bunch of things happening all at once, right? We have this variable all students that's been renamed. We have the names of the students that have been changed, and these things got moved to separate files. And so that's why we have this merge conflict. So again, I really have to know what the code, the intent behind the code here, because we want J's changes. Like we want J change this to a better variable name. We want to keep that. We needed to change the student names. I want to keep that, but I also want this stuff in separate files. So I am going to accept the changes from my branch to get rid of the student class and this stuff, but I know that I need J stuff, and I actually am going to have to modify some of my other files. So let me go ahead and open up, I think it's all students. And I'm going to go ahead and I'm going to copy this stuff. And so this is actually a fairly tricky merge conflict to resolve. This is not, I would say, a trivial merge conflict. Because there's so much, there's so many changes happening at once. And what we're going to talk about in a sec is how like we could have handled this differently to avoid some of this stuff, to avoid some of these merge conflicts. And I am going to just sort of redo my work here that I did before. And this is pretty common, like when dealing with merge conflicts, sometimes you just have to do a bunch of manual stuff. Sometimes you can be a bit more clever and elegant, but sometimes you can't. So let's go ahead and do that. And I'm also going to use the git move command, which will tell Git that I'm changing a file name. So Git doesn't just think it's deleted. And let's move all students to all double underscore of J's students PY. And now over here in app, I do also have to make these changes. So from all of J's students, we're going to import all of J's students. And maybe I could have left the file name all students. That's a little bit of dealer's choice, but it's good to see this example. And so now that I've made that change, I can safely accept this change here for my branch. And I can say accept current, right? Because now I'm importing the students, they're correctly built, they have the new names. And if we keep on going here, we see student list, and we see actually there was a change here. So Jay, my apologies. Actually, I did a terrible job as your code reviewer. We had a bit of a miss here where all students needed to be renamed as well. So that's actually a great example of what code review is meant to catch. So we can just make that change here though. And again, this is a pretty complex merge conflict because it has so many different things happening. And as I'm looking through this, I see that it's pretty much done and I can hit complete merge. Before I do that though, I've been doing a lot of talking here and I want to see what questions folks have or people are curious about before I hit complete merge and we move on to the next step. And also I just want to see how people are tracking. Like, have we gotten a little lost in the sauce or how are we doing?
It all makes sense to me.
Cool. Um, Again, I want to emphasize like a couple key takeaways here. This is a pretty challenging merge conflict, and the issue was from the renaming and so many things happening at once, right? A lot of merge conflicts will be a lot simpler. A lot of the times you can just, identify, all right, I want these changes, I don't want those, and it's a couple clicks and we're done. But sometimes it is this more complex step of I really have to walk through the code and see what's going on. And so now I can hit complete merge. And now if I type, and let's close this out because we in fact had renamed that file. If I type git status, I see all conflicts fixed, but you are still merging. Use git commit to conclude merge. I see a couple things here. This VS Code config file that I don't really want. So let's get rid of that. And I should probably add that to the .git ignore, but we can worry about that later. We see here, because I used that git mv command, instead of just plain old mv, Git knows that this file has been renamed. So there's git mv and there's git rm, and they are nice to use for that reason. We see here changes not staged for commit. So it looks like I've modified this file, but I haven't added it. This is maybe just getting a little confused because they do have it over here. So let's just do git add all of J students. And if I do git status, we see we've got these. It's important to do a visual check of files because this stuff can get confusing. So this looks good, right? This has our new name. We're importing the student class, and these are the new names. Let's also make sure our student class looks correct. And let's take a look at app.py because this is the big one, right? And so, Andy, as to your point earlier, if I'm fixing a merge conflict, there's no way around this sort of manual review process. And again, even as a junior engineer, like fixing these merge conflicts and then being in a high trust environment where I do this and I'm reviewing it, and then I'm like, all right, this is ready for someone else to review, right? Where the goal is the code review is to catch things I might have missed, but really I'm sharing code for people that, as best I can tell, is good to go. And we're fixing a simple merge conflict, I might have to talk to a couple people to understand the code, right? It's not always a straightforward fix. And so all of this looks good. If I hop over here to the students, you saw we made that change, so that looks good. So everything looks good here. If I do git status, we see these changes to be committed. So let's do git commit. Let's add a commit message here and let's explain stuff. And let's just say fixed merge conflict features here are students class in different file. All students renamed to all of J students and in different file. Get students endpoints, refactored appropriately. All right, and you can maybe write a bit more if you wanted, but this sort of captures the idea. And now let's go ahead and push this code up. So we've done all this work. so that when I go back here to where I have my pull request, and in fact, if we think of our tail draw diagram, if we go back to this feature branch workflow, what we just did is this, right? All the work is done on my local machine, on my feature branch, because this way, even on my local dev machine, the main branch is always protected. And I fixed it, and now I'm pushing those changes up to be reviewed. And we should no longer see any merge conflicts on the PR. And I just need to exit full screen here. And if we hop back to our pull request, and let me make sure I've got the right one here. So bear with me a moment, folks. Here we go. For our Avenger Git Workshop pull request, there are no conflicts with the base branch because I just fixed them all on my local machine. If I look at the commits, we see this one we just did a minute ago. And we see here, this is where we fixed the merge conflict and did all that stuff. Right, if we want to, we can view the full changes. If we want to on the pull request, we can review files changed. So I absolutely would want Jay to review this. Jay, can you review to make sure I didn't accidentally break your code changes? Jay would review, he would give a thumbs up, and then I would merge. Right. And again, to go back to that same diagram, I've now merged my feature branch with those fixed changes onto main. And now everyone needs to pull that down onto their main. So I would go to my VS Code and check out main, right? Our main 2 branch, which is our pretend main. And I would pull down those changes so that I now have those most recent changes to main on my local branch. And so there's a couple steps here, but that is the full and complete workflow for fixing a merge conflict, pull requesting it up, sending it up, and resolving it. So what questions do folks have? What's on people's minds? What are you all thinking about? So I have a question. What could we have done to avoid these merge conflicts in the first place?
Not work in the same file at the same time.
Not work on the same file at the same time? Absolutely. What else? What about? Oh, go ahead.
Have predefined naming conventions. So like have an agreement, hey, this is what we're going to name our files, and this is what we're going to name each part of it.
Yep, exactly. We could have predefined naming conventions. What about how we? Oh, go ahead, please.
You pay attention when you're approving something to be added to main on the GitHub. Make sure that you're looking for those conflictions.
Yeah, absolutely. Like the code review process is super important. What about how we defined these 2 tasks? What are some of the problems with these tasks that sort of created a situation for merge conflicts to occur?
They were dependent on each other. So maybe not define a project that 2 different people that are going to be working on the same functionality of a feature.
Well, they weren't dependent on each other, but they did touch the same part of the code. Right. I didn't need Jay's work to be done to do mine, or vice versa, but we absolutely did touch the same part of the code. But let's talk about this issue that Jay had, because I did construct this one on purpose to have some problems. There's like 4 separate tasks in here. One is we didn't get to it, but to add a feature so that the get endpoint. Oh, no, Jay, you did do this. I'm sorry. So that the goodbye endpoint accepts an ID for a student. And I think we, in fact, didn't have a goodbye endpoint. So this is one feature right here. Renaming the all students dictionary to something else. That's really a separate task that's totally unrelated to this. And then giving all the students a different name is also a separate task, totally unrelated to this. Right? So there's actually 3 tasks in here. And there's a couple problems. I asked Jay on purpose to do all this work in one single commit. If he had done it in separate commits, we might not have had the merge conflict, right? Because Git thinks in commits. That's how it compares things. But also, these don't belong together in the same issue. Like, they don't have any relation to each other. And as you guys can kind of see, every time you increase the scope of a task, you sort of increase the surface area for a merge conflict, right? So having 3 different issues, even if these 2 were tiny, actually is better. And that might have obviated or gotten rid of our merge conflict entirely. Similarly, for this task over here, this is 2 completely separate issues, moving the all students dictionary into a separate file and moving the student class into a separate file. Again, it's a small thing, but when you have 5 people actively working on a code base, stuff like this starts to matter. So that's kind of the main thing I want to point out here is that like these were not very well scoped issues. They had too much like unrelated things in them, and that contributed to the merge conflicts. As well as the fact that we did all this stuff on one commit. And I just want to pause and check in and get folks' thoughts on that, if that makes sense, if people have questions, what's on people's minds. Okay, cool. So now that we've kind of walked through this in depth, I do have an exercise for you guys. And let me go ahead and pull it up. And bear with me just 1 minute here. So this is probably best done after lunch. I don't think it will take you guys more than 30 minutes. This is to be done in your group project teams. And let me just scroll down to find the link. So just bear with me here. Here we go. Again, there's a couple links here for various resources. Everything we kind of walked through from talking about merge conflicts, feature branches, everything is here, and I'll share this link as well. And then we have this assignment. And so each group project team, you will want to clone this repo. If you want, you can fork it just, or you might just want to make a copy of it. Forking should be fine. I think this should be public. Let me double check here. Yeah, it's already public. So you guys should be able to fork or make a copy of it onto your own. And it's a Django React app with the Pokédex. And the goal is in 30 minutes for you guys to practice this feature branch workflow. And so set up a team repo, make sure everyone has read-write permissions to the team repo, and then each teammate does one of the assignments and use this feature branch workflow, make a GitHub issue, make a branch to do your feature branch work, make a pull request, share with your team over Slack the pull request, ask for a review, and merge it. And you'll see here that I've created a number of assignments, and the assignments are sliced up pretty fine. Here's one to make the Django model for Pokemon moves. And I'm just giving you guys the code because that's not the point. But then here, say, is the routes and the view function for Django moves. So there's going to have to be some communication and coordination around which work gets merged first and which work is dependent on other work. And make sure after you merge each pull request that main still works. That's your goal, right? That main should always be in a good state. If there's more assignments than teammates, everyone should do one, and then you can tackle on to the remaining. Make sure the program runs, and the goal is really communication and coordination and sequencing. These assignments are maybe a little more finely sliced than in a real world situation, but it will provide a good general guide on how you can divide up work amongst the team to work on stuff in parallel. And Okaino, as to your question before about like how to fake data, it does help you see it a little bit, right? Because if I'm working on, say, a Pokemon moves front end, if we don't have this endpoint that exists yet, maybe I just write a fake function for all of this and it just returns some JSON and it's just some JavaScript here that sits here until that feature is working. And so sort of identifying the different parts of your program and how the data gets passed around is a good guide to thinking about where I can fake data. Do folks have any questions about this assignment? Okay, cool. I don't think it'll take you guys that long. I do think it will help with practicing the communication and the workflow because doing it with the code base that you know where a lot of these steps are done will force you guys to focus on that bit. So that's really the goal of this exercise. Let me go ahead and stop the recording and we can wrap up.